section 910 is the culmination of everything we've been working with logarithms, and it's how to actually solve exponentials. So earlier in the chapter, we were trying to figure out how to actually solve when t was in the exponent, and we were kind of guessing and checking, and I said we'll get to it eventually. Well, here is your day, so congratulations, you have made it. Okay, so the steps to solve are written right here for you, and there's also a theorem here, which is the change of base theorem, which says if we have log base b of a, that's the same thing as log of a divided by log of b. Okay, and the reason we have that is so that we can do questions like example A on our calculator. The only base your calculator has is base 10. So if you wanted to evaluate something like A, log base 7 of 25, well, you don't know 7 to some power to give you 25. So in your calculator, all you type in is log of 25 divided by log of 7. Okay, and if you type that in, you should get something like 1.65. Okay, only key here is please make sure that you close your parenthesis on the 25 before you divide, okay, or do log 25, hit enter, and then divide by log of 7, because your calculator automatically opens a parenthesis, so you need to close that before you divide. So that's the only trick there. Okay, part B is where that really solving comes in. So what we're trying to do is we're trying to solve for x, which is in the exponent. So what we need to do is first step says to log each side. So I'm going to say log of 12 to the x plus 5 equals log of 17. Now at this point, you're like, oh, let's cancel off the logs. Well, that didn't help you get anywhere. Okay, so here's where the power comes in. Yesterday, when we were taking coefficients, okay, we took a coefficient and we moved it to the exponent. Well, we can use that same property and take this exponent and move it down out front. Okay, so same property brings that down. So when we bring that down, that now says x plus 5 times the log of 12 equals the log of 17. Well, that's pretty awesome because now we have a quantity times the log. If I'm trying to solve for x, I can divide each side by the log of 12. Okay, so now if I type that in, I'm going to get x plus 5. And then in your calculator, type log 17. So in your calculator, okay, either make sure you close that parenthesis or you hit enter, okay, before you divide, and you should get 1.14. Well, now it's really easy. All you do is subtract 5, and you get x equal negative 3.86. Okay, so nice 3 little simple steps. So we'll try it again, just to make sure we've got the right idea. Example C is a little different because we've got a 4 out front. So you got it. Divide by 4 first. So now I have e to the n equals 6. Okay, now remember, e is a button on your calculator, not a variable. So the variable I'm solving for here is n. Now last time we logged it. If we have an e, we should, you got it. This time we're going to ln each side. Okay, so ln because of the e. So now I've got ln of e to the n equals ln of 6. Well, ln of 6 is a button on my calculator. Okay, so that's going to give me 1.79. Okay, ln and e on the left-hand side cancel, so I just get n to equal 1.79. Well, that's pretty nice. Okay, let's see if I can trick you. Probably not. Example D, 17 to the 4x minus 7. So again, I notice x is in my exponent, so I'm going to solve my steps. First step is to log each side, so 17 to the 4x minus 7 equals log of 25. Again, I'm going to use those properties that say an exponent is the same thing as a coefficient. So I can bring the 4x minus 7 out front. So I've got 4x minus 7 in parentheses times the log of 17 equals the log of 25. Well, in solving for x, I want to get rid of this log of 17. So I'm going to divide each side by log of 17. So I'm left with my 4x minus 7 on the left side because my logs cancel. And then log 25 divided by log 17. I don't know. Oh, I put this in my calculator. So log of 17, hit enter, okay, divide by log 17. That should give me 1.14. Please make sure you're doing this on your calculator, that you're getting the same numbers. So 4x minus 7, okay, so then I'm going to add 8. So that's going to equal 9.14, divide by 4, so x should equal 2.03. Okay, very, very good. An example E. E, get it? And then there's another E. So again, remember E is just a button on your calculator and N is your actual variable. So because of the E, I need to ln each side. Okay, so then I'll ln each side. Well, ln of 32, again, is just something on my calculator, so 3.466. The ln and the e's cancel, so I'm just left with 8n plus 2. So solving for n should be pretty simple. I'll subtract 2, so I'll get 1.466, divide by n, and I should get 0.183 for my n. Okay, so only trick here, if you don't see an e, log it. If you see an e, ln it. Okay, so let's see if we can answer some story problems, everyone's favorite. So F says, at what interest rate, compounded continuously, there's one of those magic words, would you have to invest your money so that it would triple, okay, in 10 years? Okay, continuous is the first one I see. Continuous means I have to use PERT. Okay, so that means that if you haven't picked up on that, make yourself a big note and highlight and circle it. Okay, continuously means you have to use PERT. So my formula is A equals PE to the RT. Well, what do I know? Well, I know that my 10 years, okay, that's going to be my time. And I know I want it to triple, but I don't know the rate, and I don't know how much money I have. Okay, well, that's not helpful. But I do know that P is how much I started with, right? P is my starting amount. So if I know I started with P and I want it to triple, I think it would be okay for me to say, then my ending amount will be 3 times P, okay, because it's going to triple. Okay, so now I still have E. R is what I don't know, but I know my time is 10. So I've got 3P equals PE to the R times 10. Okay, well, I'm solving for R, so it'd be nice if I could get rid of these P's, which I can. I could divide by P, so that will cancel, and my P's will cancel here. So I'll get 3 to equal E to the 10R. Well, now it looks like the ones we were just doing, because I'm looking to solve for R, and because of the E, I have to ln it. So I'll say ln of 3 equals ln of E to the 10R. Okay, well, ln of 3 is on my calculator, so 1.098. ln and E cancel, so that equals 10R. So if I divide by 10, I'm going to R to equal 1.098. Okay, now I'm not sure if I answered the question. The question says, at what interest rate? Oh, so R equals 0.1098, which means my interest rate is 10.98%. So make sure you just do that last step and turn it into a percent. All right, that was confusing. Let's try another one. Suppose you invest $200 in a savings account paying 4.25% interest compounded continuously. Okay, there's that word again. And that means I'm using PERT. How long would it take for your account to go to $300, assuming no other deposits or withdrawals are made? Okay, so I've got my formula, A equals PE to the RT. Seems like I have more information this time. So it says, suppose you invest $200, so that would be my starting amount. E is just E. Let's see. Oh, savings account 4.2%. So that'd be my rate. So 0.0425. I don't know my time, so I'll throw in a T there. And I want it to grow to be 300. So I'll plug that in on the left. Okay. So now I'm solving for T. So let's divide by 200 on each side. Okay, so 300 divided by 200 is 1.5 equals E to the 0.0425T. Okay, now because I'm solving for something that's in an exponent and I have an E, I'll ln each side. I'm really hoping you're getting used to ln'ing each side when you see a T. All right, so my ln and my E cancel over there. So on the right side, I get 0.0425T. ln of 1.5 in my calculator is 0.405. Then I just divide by 0.0425. So T should equal 9.54 years. Okay, so similar to the last one, we can use the same formula to solve for either an interest rate or a time if we have other information. Okay, using the ln because of the E, we can bring those down out of the exponent and solve. So this is a really nice problem solving thing that we can do. And then one last one, hang in there, you guys are doing a great job. Letter H says, suppose a colony of bacteria grows according to this equation, where n sub 0 is the initial number of bacteria and t is the time in hours. How long does it take for it to quadruple in size? Okay, if you remember my hint, if you don't like these variables, just rewrite them. So I'd have A equals P e to the 2t. Okay, so if you don't like them, go ahead and just write them back here. And this time I want it to quadruple in size. Again, I don't know how much I started with, so I'm just going to call that P, but I know quadrupling in size would be 4 times P. So then I have e to the 2t, and I'm solving for t, so I can divide each side by P. So I'm going to have 4 equals e to the 2t. Now again, I'm going to notice I'm solving for something in the exponent, and I have an e, so I need to ln each side. Okay, and then the ln and the e's cancel. So on the right side, I just get 2t, and then ln of 4 is in my calculator. So I get 1.386. Divide that by 2. So I should get 0.69. And then I'm just reading carefully, and then this time, this is in hours. Okay, so solving for variables in the exponent is a really valuable skill, but I'm sure you might have some questions, so go ahead, think it over, write some down, and bring those to class tomorrow.